Okay, I really hope that everything is big enough to read for you. I can even increase this a little bit. Yeah, but I think it should be good, right? Let me just... okay. I mean, I already zoomed in 25% overall, so I think this should be okay. We now have a starting point for our code. We have an actual game that we can run, even though it doesn't do much. In fact, it really does nothing. But yeah, we now have something to work with. So now let's see what we have to do. Let's go into NClass and create a new project here. And I'm just going to call it T-Rex runner, I don't know. And then I can add a new diagram here and call it, I don't know, game. And let's see. First of all, when we go into the source code here, you can see that in the project there's already a class called game1, which is a subclass, a derived class of the game class, which is an abstract class from the MonoGame framework. And it provides all of the functionality for your game, actual game loop, stuff like that. So yeah, so our game will, our main class will be a subclass of this game class, but it will not be named game1. That's weird. I'm actually going to go ahead and rename that to T-Rex runner game. There we go. It's a much more fitting name. So yeah, that should be good. Okay, so let's go into NClass and see what we need. Obviously we have our T-Rex runner game class that we just created. T-Rex runner game. I think I have a more appealing style here somewhere. We just go into the options real quick. Options, style. No, I actually don't. Well, it doesn't really matter. So we have a class here named T-Rex runner game, which is derived, which inherits from the abstract class game from the MonoGame framework. We're not going to further detail the game class. We just want to show that our T-Rex runner game is a subclass of that pre-existing class, like this. This is a generalization, so this means that our T-Rex runner game inherits from the game class. So it basically inherits all of its properties and methods. And we created is relationship here. So let's see what we need. First of all, let's look at the game. Let's refresh the page. Okay. Can I close this here? Okay, great. So yeah, so we have the game here, and let's analyze this. What does this game consist of? Well, first of all, we have a couple of objects here on the screen, right? We have a high score or a current score, a scoreboard basically up here. Let's call this the scoreboard. We have the player character, which is this little T-Rex, and we have a ground floor thingy that moves along the screen while we run. Let me just go ahead. We have the clouds here. We have cacti, or let's just refer to them as obstacles. We have this game over screen. So yeah, how can we generalize this? Well, first of all, obviously we have our game class, or T-Rex runner game class. And in our game, we will use these different objects, which do have some things in common. Let's in our context, refer to all of these objects here as game entities. All of them have something in common. They can be updated, they can receive a message that they should now perform an update on their current state. And for that, we're going to create an interface, and we're going to name it game entity. Whoops. That's not how we spell entity. There we go. And we will use this interface to generalize all of our game objects or game entities, sort of as a contract to their common behavior. So we know that we do have some sort of entities in our game, and different implementations of that game entity interface. Now, we know that there's a T-Rex that needs to be controlled by the player. So let's go ahead and create a new class named T-Rex. Or call it whatever you want. Dinosaur, player character, I don't know. I'm just going to go ahead and call it T-Rex. And this T-Rex is going to be an implementation of our game entity interface. And the I in the name is just C# naming convention. In C# usually the names of interfaces are prefixed with an I. So yeah, we're going to stick to that convention, of course. And our T-Rex will be an implementation of the game entity interface. Now, what do our entities actually have in common? Like I said, they all need to be able to be updated. So we're going to add a method to our interface here, which will not return anything. And it will be called update. So now we know that our T-Rex class, since it implements this interface, will have a concrete implementation of this public method here. Just to be clear, we're going to put it here as well. But actually, we need some parameters, some arguments here in this method. And in the MonoGame framework, there is a class called GameTime. And the GameTime class encapsulates time values, such as the number of seconds that have passed between frames. And we need that to calculate the position of our entities and stuff like that. And yeah, for example, we need to move the background, and in order to move the background by a number of pixels per second and stuff like that, we need to know the time values, the number of seconds that have passed, stuff like that. So since we're always going to need that in our update loop, or we will in most cases need that, we will pass an instance of the GameTime to our update method. So let's repeat that in here. And in the method, expect an argument of type GameTime, which is just named GameTime as well. And yeah, that's it. And another thing that all game entities have in common, maybe not all of them, but most of them, is the ability to be drawn to the screen, rendered to the screen. And so we're going to add a new method that is also of return type void, so it doesn't return anything, it just does stuff. It's going to be named draw. Let me just actually zoom in a little. I think this is really small for you. There's another method now named draw, and in order to be able to draw something, some sprite asset to the screen, we need, for example, we can use something called a Sprite Batch, which is a class in the MonoGame framework. So we're going to add a new argument here in this method, in this draw method of type Sprite Batch, which is just called Sprite Batch as well. And we're going to use that in order to render entity-specific graphics to the screen. Some entities may not need rendering logic, but for reasons of simplicity, we're going to just assume that all entities have some sort of rendering logic. If they don't actually need that, then their draw method will just be empty. It won't do anything. It will still be called, but it won't do anything. And then, oh yeah, maybe I should say something about the Sprite Batch real quick. Let's go back into MonoGame here. And like I said, the Sprite Batch can be used to render stuff to the screen. And actually, you see in this stub here that was created for the game, it actually has a field of type Sprite Batch here. And it creates a new instance of Sprite Batch in the load content method, which is inherited from the game class, and it's overridden here. And then in the draw method here, it also takes an instance of game time, and we should actually include that in our draw method as well. Yeah, what you can do here in the draw method, you can use the Sprite Batch to actually draw stuff. So I have a draw method here in the Sprite Batch class that takes a texture 2D object that I want to render to the screen. It actually has a couple of overloads, which basically, yeah, are all responsible for drawing stuff to the screen. And it's called Sprite Batch because actually the concept behind this is that you don't want to make to send a draw call to your graphics card for every single sprite. Usually what you do is you basically accumulate them in a batch and then send the entire Sprite Batch, hence the name, to the graphics card. So basically you say, okay, this T-Rex sprite, this high score sprite, this cactus sprite, and this floor sprite are all contained in this Sprite Batch, and this Sprite Batch should now be processed by the graphics card. So in order to do that, I can do something like Sprite Batch dot begin, which will tell the framework that now it should actually, now it should actually make draw calls. In fact, actually, hold on. Let me just type this real quick here. Something is wrong with my keyboard layout here. Okay, so first I call the Sprite Batch begin method, which will tell the framework, okay, every draw call here now will basically be queued until I call the end method, and which will then cause all of the draw calls to be sent to the graphics card. And this way you can save performance. Actually, in a game this simple, it's not that big of a deal to just make single draw calls. But just so you get an idea, I mean, other games may have thousands and thousands of sprites, and if they were to send draw calls individually for each one of them, that would just be a huge waste of performance. So usually what is done, a Sprite Batch is used here in this MonoGame implementation. You use a Sprite Batch, call the begin method, make all of your draw calls here with the draw method, and then call the end method, which will then actually send the commands to the graphics card. Okay, so now that this is all clear, let's go back into our diagram and actually make our draw method receive an argument of type game time as well. Because even in the rendering logic, we may sometimes need to refer to the time that has passed in our game to make some calculations and stuff. Yeah, and now I will just copy this. I mean, just by the due to the fact that the T-Rex class implements this interface here, which is indicated by this realization relationship here, it is implied that obviously this class implements the draw method as well, but I'm just going to redundantly put it here just to make it clear. Okay, and actually I accidentally made it private, but it's going to have to be public so that we can call it from outside of the class. Okay, I just realized that I did not record in HD, or not full HD, so I hope you didn't miss any anything that was important in terms of text. But I think I zoomed in enough for you to be able to see everything. I actually now increased the resolution of my recording application. Let's just go in Visual Studio here. Yeah, I think it should be good. Yeah, I think now the resolution should be fine, so you should be able to read everything. Okay, so now with this out of the way, like I said, in the comments, if you have any trouble reading stuff, if something is too small or I don't explain it well enough, just let me know. But I think for now we should be good. So let's go back into NClass and take a look at what else we need. Okay, so we know that there will be a T-Rex game entity that will be represent our player character. But what else? Well, for example, we identified this scoreboard here as an entity, so let's add that as well. Add a new class that describes our scoreboard. And it will also implement the iGame entity interface. Whoops. There we go. And yeah, I will actually save the time and not actually put those two methods here as well, because it is actually implied that logically the scoreboard class will implement these two methods because it has to. Okay, so let's go ahead. What else? Let's take another look here. Let's restart this, or maybe just revisit the website. We have a scoreboard, we have the player, we do need the floor somehow. And what I figured is that we will need some class that is responsible for actually managing how the floor moves and how the floor tiles are spawned. Because if you take a look at it, basically what happens here, if I start it, whoops, the floor repeats itself, right? But sometimes the floor looks a little different. It has these little bumps and holes in it, and it seems to be random. The gap between those little bumps seems to be completely random. And what I think is happening here is actually pretty simple. If we take a look at the original asset here, where do I have it here? Just open it up here in Photo Filter. There we go. I think what's just happening here is, so this is our ground, right? It's a really large sprite. This entire thing down here. Let me just zoom a little bit here. And really what is happening, what I think is happening here, is that basically it spawns, so to speak, either the left half of this giant sprite, like this, Oops. So the game either spawns only the left half or only the right half. And which half is spawned is completely random. So sometimes it will spawn the right half of the sprite 3 times in a row, which will make the floor appear especially bumpy, and sometimes it will just spawn this flat part of the ground here. So yeah, this makes this a little more, it gives it a little more variation, and it doesn't have a predictable pattern. So yeah, sometimes this is what I think is happening here. So sometimes it just spawns the flat part of the sprite here, which is the left half of it, and sometimes it spawns the bumpy part here, which is the right half of the sprite. So you need some class that manages this logic, that encapsulates this logic, and spawns these floor tiles, basically, and moves them across the screen while factoring in the speed that our character is running at. So let's go back into our diagram here, zoom out a little bit. I think now with the resolution increase, you should be able to read everything. So let's go ahead and see what we can do here. So we need some sort of class that manages these floor sprites. So let's call this floor ground manager. And it will also be an implementation of the iGame entity interface. And the ground manager needs ground tiles to move, to move them across the screen. I don't know if we should actually describe the ground tiles as their own class or just have them be textures in our ground manager class. We could do both. Both methods would be perfectly fine. Yeah, let's for now keep this in mind. There will be a ground manager. Okay. What else? Let's take another look at the game. We need a game over screen, but that's not as important right now. Let's take a look. Oh, we need to be able to spawn these little cacti and also those little flying dinosaur thingies. And let's generalize them. Let's refer to them as obstacles. Here, let's take a look. It randomly spawns those little groups of cacti as obstacles. And sometimes it also spawns those flying dinosaurs. And yes, you can see it's completely random how these are spawned and how many cacti at once it spawns. And what I think is happening here, hold on. Okay. If we take another look at the sprite sheet, we have all of the different cactus sprites here. And what I think is happening here is that these are actually the different groups that can be spawned, meaning that, hold on, zoom in a little. So basically the game randomly either spawns a group of a single cactus here or a group of 2 or a group of 3, or let's generalize it even further. It either spawns a small group, a medium-sized group, or a large group. And this applies both to these small cacti as well as these bigger ones. This is the small group, which is also just one cactus. Then there's the medium-sized group, which is 2 cacti, and then there's the large group, which is actually 4 of them, one of them being a teeny tiny itty-bitty one. So yeah, I think this is what's happening here. At least this is going to be the way that we implement it. But I've looked into it, I've analyzed it a little bit, and I think they are actually ordered here in the as the groups they appear in. So I think this should be fine. So yeah, what we need is a class that describes an obstacle. So these little dinosaurs here can be obstacles, but these cacti can also be obstacles, so they have something in common, so we need a base class for that. So let's go into our diagram, create a new class, and call it obstacle. Yeah, but since obstacle as itself, it doesn't make sense to create an instance of something called obstacle in a context where there are concrete obstacles such as cacti and flying dinosaurs. So that is why we will make this class abstract, because we will never create an instance of this type directly. We will always create instances of classes that are derived from the obstacle class, subclasses of it, which is cactus. Well, let's just call it cactus group. And flying dino. And these are both subclasses of the obstacle class. Whoops, that's the wrong way. Yes, okay. There we go. And apparently, or obviously, an obstacle is also a game entity that can be updated and drawn. So this class will also implement the iGame entity interface. So this way, now that all of our classes implement this interface, we created a generalization, and we can basically just have the game iterate over all instances of iGame entity and call their respective update and draw method. So this way it will be very easy for us to update and render all of the entities on the screen without having to know what specific entities are currently on the screen. All we need to know is that they are of type iGame entity and they implement these methods, which is guaranteed by providing the interface. Okay, let's go ahead. So we have obstacles, which can be either a cactus group or a flying dino. These obstacles have to be managed as well, just like the ground tiles. There has to be some class that determines randomly what kind of obstacle to spawn and how they move on the screen and stuff like that. So we will have a class that is responsible for that encapsulates that kind of logic. So let's put this back here and create a new class that is named Obstacle Manager. And yeah, what the Obstacle Manager will do is it will use some obstacles. It will create obstacles on the right side of the screen, move them across the screen and yeah, determine what kind of obstacles should be spawned and stuff. So we know that there's a relation between these two, and basically the obstacle manager, let's just use a regular association here. The obstacle manager has a one-way direction to the obstacle class, and what it does, it creates them. So the obstacle manager creates obstacles. So I think that's fine. And let's have the obstacle manager actually be a game entity as well, because it also needs to be notified when the game updates. It will probably not have any drawing or rendering logic, but that's fine. There we go. Hope this doesn't become too messy, but let's see.